Okay, we're going to get started here. Just show my face here at the beginning of the webinar. My name is Patrick Hill. I'm one of the founders here at Triple Point. I've been working with Lagoon Systems for the better part of 18 years and have probably worked directly with 100, but probably been on sites of, I don't know, maybe 500, 600 lagoons. So I'm trying to be here to share some of my knowledge with you. I hope you find it useful. Today, we're going to talk about algae and duckweed mitigation strategies. Yesterday, at our previous webinar, we talked about what the causes of algae and duckweed growth are, what the impacts of that growth is. So this kind of goes along with yesterday's webinar. If you weren't able to make it yesterday, I encourage you to go back and watch that once we post it here in the next couple of weeks, because these two really kind of work hand in hand together. So this webinar is part of our Masterclass series of webinars that we've been working on for probably the past 2 years, with the goal of, starting from the very basics of lagoons to what is a lagoon and how does it work, all the way through to this data analysis and troubleshooting, which we'll hopefully be able to do a couple modules on in the fall and wrap up our entire Masterclass series. And so we're really hoping this to be something that anybody who's new to the business industry or new to lagoons, if you're an engineer, you can go through, watch all these classes and really get a good sense, get a good grounding in lagoons and potentially be a lagoon master when all is said and done. All of our webinars can be found on our Lagoon University platform, lagoonuniversity.com, or you can go to our website, click resources at the top, and then the drop down, you'll find it there. A really good resource. You can get on demand and free webinars from this particular resource. Really highly recommend you go check it out. If you're an engineer that needs continuing education hours or PDHs, professional development hours, you can get them there, take the class, take the quiz, get a certificate. If you need CEUs, if you're an operator, we do support a lot of CEUs in a lot of different states. Each state's a little bit different, so we do our best. But yeah, you can definitely get a wealth of information on this site. So I really encourage you to check it out. Okay, so today we're going to talk about algae and duckweed, particularly how to control it, how to mitigate it. So I'm going to take a quick step back and look at the impacts of algae and duckweed and talk a little bit about the growth cycle. This will be a little bit of a recap from yesterday, but I think it's applicable and important to set the kind of foundation for the rest of what we'll talk about when we talk about prevention, abatement, removal, and mitigation. And then I'm hoping here at the end that we'll have a few minutes for Q&A. So first, talk about impacts. So I think what's really important to know is that, algae and duckweed to some extent are part of the lagoon process and are very important to the lagoon process. So the EPA put out this design manual, or this manual for lagoons, in 2011, and it talks in there about all the different benefits of algae for lagoon systems. So it's, it may seem like a nuisance to us, and if you have too much algae growth, it definitely is a nuisance, but the reality is it's actually really needed for the process. So a couple of things that I'll mention here over the course of the next two slides is that, algae they act like a plant, right? So they consume carbon dioxide and they release oxygen. And so one of the primary purposes of your lagoon system is to break down the carbon, right? Break down the BOD. And when you break down the BOD aerobically using the type of bacteria that you want, you end up releasing carbon dioxide as part of that, a byproduct of that process. And so what algae does is it actually takes that carbon dioxide and then converts it back into oxygen. And this is a really good symbiotic relationship because you've got the heterotrophic bacteria that are breaking down the food and consuming oxygen in the process. And then you've got the algae that are then taking that carbon dioxide that's produced by the heterotrophic bacteria that's breaking down the BOD, which is what you want, and converting it back into oxygen. And so it's a really, really great symbiotic relationship between the two. And for every pound of algae, you get 1.6 pounds of oxygen, and that oxygen is free, right? That doesn't cost you anything. You don't have to to use your blowers or whatever, it provides it for you for free. So that's really awesome. And so like the book actually goes on to say, like, this is the key to successful operation of a lagoon system is the oxygen provided by algae within it. So I think that's really important to notice. Some of the other sort of positive impacts are, algae will assimilate some BOD and nitrogen and phosphorus into its cell wall, so it has kind of a nutrient reduction and slight BOD reduction capability to it. It prevents odors from emitting from your lagoon. It saturates the water with DO, and that DO actually helps to neutralize the H2S that might be building up because of anaerobic digestion on the bottom. So that's really great, right? We don't want a stinky lagoon. It discourages the growth of certain types of pathogens, so it actually has a disinfecting effect to an extent, and it will precipitate metals. So all these things are really important. The other thing that's good about this is that about algae is that it'll actually raise the pH in the water. And so you might have noticed, like if you monitor your ammonia effluent, that you typically put out way less ammonia in the summertime than you do in the wintertime. And a big part of that is that algae is coming in, it is increasing the pH, and then it is shifting the balance of ammonia from the NH3 form of ammonia, which is typically what you find on your permit. That's the gaseous form of ammonia. That's the form of ammonia that, if it makes it into the downstream environment, will actually is toxic to fish and invertebrates and the foundation of the aquatic food chain. And it will convert it into ammonium, which is more the liquid form, which is way less toxic, way less harmful. And so it's a good environmental benefit and also a good treatment benefit during those summer months when algae is thriving. Negatives. So this is probably why y'all here, honestly, like you don't want to tell me that there's no point in having this webinar. The negative impacts of algae can be higher than the positive impacts for a lot of lagoon systems. And we'll talk about why that is. We talked a little bit more about it yesterday, but we'll talk a little bit about it today. So Dr. Linville Rich is sort of one of the godfathers of lagoon expertise, passed away in 2011, unfortunately, but did lots and lots of studies on lagoons. And we refer to his work a lot, and I actually refer to it in this presentation twice. And he came to this conclusion that most of our TSS BOD violations are a result of algae and not necessarily what's coming in from our collection system. So it's not that the lagoon is failing to treat the influent constituents of BOD and TSS. It's that it is doing a great job of treating that, but it's helping algae grow, and then those algae are then showing up as BOD and TSS in your effluent sampling. Another study done here in Colorado, my home state, found that of 24 Colorado municipal lagoons, 2/3 of them, their effluent violations were basically due to algae, right? Too much algae growing in their pots. So it really does have a really big impact and can literally, if it gets out of control, algae can literally cause you to violate your permit, which is obviously not what we want, and that's why we're probably here. Some of the other things is, while algae does assimilate the nutrients, the phosphorus and the nitrogen into its cell wall, and that in some ways is a good thing, because then those nutrients can flow out of your effluent, as you can see here, and flow downstream, and they don't accumulate in your lagoon as much. They also have an impact on the downstream environment. So they can cause what we call harmful algal blooms, because as they assimilate those nutrients, they flow downstream, you get a nutrient concentration, let's say in a drinking water reservoir or in a lake or a bay, and that can cause major health problems. Like people who swim in that water can get sick, they can possibly die, it can cause drinking water issues, etc. So that's not a good thing. The other thing is, if you're trying to treat for, let's say, total phosphorus, let's say you have a total phosphorus level limit of 0.5 or less, and you're trying to use chemical precipitation, possibly chemical precipitation and filtration, the algae is resistant to bind to the chemical. And as we talked about, the algae in their cell wall actually has phosphorus in the cell wall itself. And so it basically limits, because it doesn't really want to bind to the chemical as well, it limits your ability to settle out the phosphorus that's in that algae. It also, the algae will actually squirt its way through, squeeze through it, like bends and contorts its way through filter media, and actually will flow right through a filter in a lot of cases. And you'll get some of the algae through the filter, but you won't get all of it. And so it can really limit your ability to get the phosphorus out. So how does algae grow? And again, this is just sort of a little important recap to yesterday to kind of set you up for when we're talking about these potential strategies to deal with algae. So this diagram here is right out of my college textbook, my college ecology class. And it shows a pond, but the principle of this diagram is exactly the same as you get in a lagoon system. You have a nutrient load coming in. That nutrient load is got phosphorus and nitrogen in it, right? These are great fertilizers for algae, just like they're fertilizers for anything else, any other plant that grows, and duckweed. You've got the sunlight that's penetrating and beating down on the surface of the lagoon. You've got this big surface area that is your lagoon. And as algae grows, what happens is sunlight penetrates down to the bottom where a lot of these nutrients are, right? The nitrogen and phosphorus. Then the algae form at the bottom and they bloom to the surface. And then they kind of hang out there pretty much all summer long. And they'll, within their 24-hour cycle, which we'll talk about in a minute. And so this can create a layer of really good dissolved oxygen at the surface because the algae is photosynthesizing, it is taking carbon dioxide and converting it to oxygen, right? But it also can cause a layer of oxygen deprived layer at the bottom, right? It can starve the rest of your pond from oxygen, which will create more of an anaerobic digestion environment that is breaking down the sludge, creating H2S and things like that, and doing so very slowly. So this is how it kind of works in sort of a 24-hour cycle. And I think it's important to understand that algae operates in different modes based on its different point in the cycle. And it's thriving, and this cycle is primarily controlled by sunlight. Okay, so during the day, it is consuming carbon dioxide and it is creating oxygen, adding oxygen. Great, we love that, right? That's fantastic. During the night, it does the opposite. It actually consumes oxygen and releases carbon dioxide. And this is solely based on the sun. So one of the more profound impacts that this has is on your lagoon pH. So during the day, your pH will raise and it can get as high as 9 or even higher, right? I've seen 9.5, right? In a really particularly bad circumstance, possibly causing you to violate your pH requirement on your permit if you have one. And then at night, it'll come right back down again, right? It'll come down into maybe under 7 or in the 6s, or 7 to 8 kind of range. And so this is the sort of 24-hour cycle. And we also find that algae kind of move around in the water column across the cycle, right? They sink at night and they raise up to the surface during the day. So they're sinking, raising, sinking, raising. And this is one of the reasons why simply putting your effluent pipe, let's say 36 inches underneath the water, doesn't necessarily work to avoid pulling algae out of your lagoon. Because of that sinking and raising effect that algae have over their 24-hour cycle. Algae also grow at different times of the year. Obviously, they like warmer water, they don't like colder water, and so you'll often see that in the summer months is when you're going to get your peak algae blooms or your peak duckweed blooms. No surprises there, right? With green algae, which is considered kind of healthy for the lagoon, and good algae that you want in your lagoon. peaking somewhere mid to end July into August. And blue-green algae, which is the cyanobacteria, the bad stuff, the stuff you don't want, and if you have it, typically means you've got too many nutrients in your lagoon, peaking kind of fall, like September, October type time frame. And this is all based on temperature and sunlight exposure. So one of the things I would say, and when it comes to mitigation strategies, is that I think understanding this algae growth cycle is really important for understanding how and when and to sample, right, and the frequency of sampling. So I think, you really got to look at your permit. You really got to understand what it says, how often you need to pull a sample, where it needs to be pulled, and what it stipulates in terms of, is there a time requirement when you have to pull a sample, right? Is it telling you exactly how to pull a sample? Is it telling you that you can only pull one sample a month, or can you pull 3 or 4 samples a month, right? And really understand that. And if you're at all confused or at all worried about it, call your regulator and ask him, right? And say, hey, like I didn't, I'd say most lagoon permits, for example, they require a grab sample, okay? And this is like a snapshot in time. So you're standing there, you pull the sample, and then they only require 1 sample a month, okay? So that's 1 sample every 30 days, that's a grab sample. That is in no way representative, in my personal opinion. This is the performance of the plant, but hey, that's what the permit says, right? And so if that's what your permit says, you can choose when to pull that sample. And if you know at solar noon that your algae is going to be the highest and your pH is going to be the highest, is that really representative of a 24-hour cycle of your lagoon? No, it's not. It's absolutely not representative. And so I would encourage you to pull it at a different time of day, potentially at the first thing in the morning or late in the evening or something like this. And again, consult your regulator, consult your permit. I do not want you to do anything that's going to get you running you afoul of any of those things. You have obligations. But if you have the choice, and most lagoons do, and if you call your regulator, I'm pretty sure they'll just say, yeah, absolutely, you can pull it when you want. That's what the permit says, right? I would pull it at that time of day that's not going to give you an abnormally high algae reading, because really that's not representative of the entire day anyway. And it won't necessarily give you a result that will meet your permit. Okay, so just to sort of summarize some of these conditions, right? We looked at this diagram yesterday, and at this table yesterday. We'll just go through it a little bit today with a little bit of, I added an extra column here, right? So if I wanted to grow algae and I wanted to create the most ideal conditions in the world to do so, I would want warm temperatures. I want shallow lagoon that sunlight penetrates through the water column really easily, so low turbidity. I want high nutrient content, and I don't want a lot of mixing. I want like really quiescent water, okay? And so I kind of took all these different conditions and I put them on a table, and I said, okay, can we do something about carbon dioxide? No, we can't do anything about that. We've got BOD coming in. We need to treat that BOD. We want that carbon dioxide to be produced. Can we do something about nutrients? Well, we could do a little bit about nutrients, and we'll talk about that. Sludge removal, potentially precipitating phosphorus. Can we do something about sunlight? A little bit, we definitely can. And we'll talk about that with lagoon covers. Temperature, we can do a little bit about. Quiescent water, we can do something about. Turbidity, we can do something about. So this is a really cool little table that kind of gets you at the like root cause analysis of what causes algae to grow, and you need to disrupt 1 or 2 of these different things to some extent to have a better management strategy. So biosolids. So this is I would say the most common reason that lagoons have quote unquote too much algae. And what I mean by too much algae is you are not meeting your pH, your TSS, or your BOD permit, right? You're struggling to meet that. And typically, lagoons are designed with 20 years of sludge storage, and typically nobody's ever removed sludge before, right? Since the lagoon was first built. And so it becomes a problem for several reasons. Number one is you've got nitrogen and phosphorus that have built up in that sludge. So you've got fertilizer there for the algae. Number two is that as that sludge builds up, it makes your lagoon shallower, right? So it is making it easier for the sunlight to penetrate down to the bottom and help form algae. And so I say one of the biggest things I recommend, right, is in general for lagoons, because sludge is an Achilles heel for lagoon systems, in my opinion, is to have a good understanding of how much sludge you've got in your lagoon and start to try and actively manage it if you need to, and mitigate it in some way. So I did a whole webinar on biosolids, 2 webinars on biosolids. So I really encourage you to go back and watch those, because they'll talk in a lot more detail about how to measure it, what the problems that it causes, how to remove it if you want to remove it, etc. But I'll touch on a few things here. So the first thing to look at is, if you have too much sludge, is to look at some kind of bioaugmentation. So this is where you're adding either bugs or this, in this case, this graph here that I borrowed from Steve Harris, who passed away recently, God rest his soul. This is a pro-oxidizer of the sludge itself. And basically you're adding something that will help break down the volatile component of that sludge. So that's the organic component. That's the undigested BOD, the nutrients, the dead algae or dead duckweed from previous years, the things that will help to fuel the growth of algae itself. And this type of methodology of putting these additives in to help break down the sludge have been around for a while. This here is showing you one lagoon that Steve studied, and was able to see about 30% reduction in the total sludge blanket volume, which is huge. And I think this is like a really good first step, and an easier step than actually physically removing sludge, is to sit there and say, okay, what can we digest in place so we don't have to remove it later? And this can be a big step in helping to mitigate some of the excess algae growth that you take. So there are tons of companies out there that do this. Aquafix, this company CBX, you can look them up. There's a lot of these out there. And again, if you're going to do it, I really, really encourage you to go back and watch my biosolids presentation, because I talk a lot about that and what to look for and what not to look for, and the different options and things like that. You can obviously go and think about dredging, which, every wastewater treatment system in the world, I don't care what system it is, activated sludge, oxidation ditch, MBR, you name it, SBR, they all have to manage biosolids, right? That is just part of wastewater treatment. And lagoons manage biosolids by storing them over a 20-year period, okay? And I think this is great, personally. Like this, you don't have to touch this for 20 years. That's awesome. Some of these other plants, you gotta manage biosolids every day, right? And it's costly. But eventually, you got to remove the biosolids. You got to clean out your pond, and that's just part of the system, and it's part of the thing. And so, there's 2 primary ways to do that, right? You could do dry dredging, which is my personal preferred, where you take the lagoon offline, get some dozers down there, you dozer it to one end, you scoop it out, right? Then you can visually see the sludge has been removed. Then you got wet dredging, right? Wet dredging is you leave the lagoon in operation, you have a dredge at the surface. It basically has an arm that goes down to the bottom, and it essentially vacuums the vacuum cleaner for your lagoon, and pulls out the sludge. Both of these are good options and something you should look into if you do end up measuring your sludge and find that you've got too much of it. The other thing to look at is aeration. So obviously this is our aerator here. There's lots of different types of aeration. I'm not here to do a sales pitch for you on aeration or on triple points aeration, but it can be a really effective and helpful tool to mitigating algae and duckweed growth. For one, is it helps to create surface tension, so it removes the sort of quiescent nature of the water, which the algae like to grow and the duckweed like to grow. They really want that, they really prefer no movement on top of the water at all. Number 2 is it strips the carbon dioxide out of the water. So it'll actually, in addition to providing the oxygen necessary for the heterotrophic bugs to break down the BOD and produce that carbon dioxide, that oxygen that you're providing to those bugs also strips out the carbon dioxide out of the water. So there's less carbon dioxide there for the algae to consume. It just creates like the foaming of the bubbles themselves, right? And the solids that it puts up in the water column, if you get good mixing going, creates turbidity. It stops the sunlight from easily being able to penetrate into the water, right, in order to form that algae, right? So that's a really, really important aspect of it as well, that it creates this turbidity. So, how effective is this? Dr. Linville Rich here, our good buddy, back in action. He did this study. He looked at aeration in lagoons, and he measured chlorophyll based on the number of watts. So like number of watts per cubic meter of water, or cubic meter of water. And what he found was the more air you add, the less algae chlorophyll you get, less chlorophyll you get, less algae you have, right? So algae being a proxy, chlorophyll being a proxy for algae. And it makes sense. It makes total sense. This is one of the reasons why if you do have an aerated lagoon now and you have air in your primary cell, right? That's where most of the time, the aeration's the most concentrated in your first cell, and it tends to taper off as you get through the system. This is one of the reasons why algae doesn't grow in there as much. It's because you're getting this turbidity, all the mechanisms we talked about. You're stripping out the carbon dioxide, right? That's preventing it. And so when you think about how much horsepower, I took this graph and I said, okay, if you had 2 days of retention, 3 days or 5 days of retention within your pond, how much horsepower would you need to get the job done? And it goes from, it's not that much actually. If you look at this calculation, it's really like 3, 6, or 9 horsepower per acre there. So, or per 1,003. So it's a useful tool in reducing algae growth within your system. Unfortunately, I think like the issue with it is that you can't aerate your entire system, and at some point you're going to have a quiescent zone, and in that quiescent zone, you probably are going to get algae growth in there. But I would say if your aeration isn't really like working very well, or it's kind of half busted, it's definitely helping the algae grow, right? I mean, how many times have I walked on a site where I've seen like a surface aerator boneyard in the corner where they just pile up all these surface aerators, and the lagoon has like 2 surface aerators and it was supposed to have 10 surface aerators or 5 surface aerators in the past, for example, or you have a diffuse system that has some major breakages in it, right? These things are not helping your algae. They're making your algae worse. And probably you would have less algae if your aeration actually works. So an aeration upgrade might be something of interest. So one method is you can target the nutrients specifically that fertilize the algae growth. So for example, phosphorus. So we know, phosphorus is really is one of the main drivers of algae growth. And so in some lagoon systems, if you're in Michigan, for example, you're required to precipitate phosphorus. You're required to discharge phosphorus of under 1. And in a lot of the states that we work in, if they don't have a permit limit for 1 now, they will probably in the future. And so you add a chemical precipitant, such as ferric or alum, that binds to the phosphorus and settles it out. And so as you settle out this phosphorus and it's bound up in the solids at the bottom, it is not available at that stage to then fertilize the algae growth. And so this can be kind of an effective tool. So this lagoon here system, we have aerators in, and so like you could feed it at the influent point, settle some phosphorus out there. You could feed it and or after cell 1B and settle out some phosphorus there, etc. And that can help to control algae across the board. One word of caution, I would say, is that these chemicals don't just bind to the phosphorus; they bind to the solids. And so if you're feeding a lot of this at the beginning of the plant, you're going to settle out a lot of solids, which you're going to build up your sludge a lot faster, and then those solids that you're settling using the precipitant are going to be harder to get rid of later. right? Because they're going to be higher in iron salts, for example. And less landfills or land application sites will want to take your solids when you go to remove them later. So it's a little word of caution. This isn't my favorite approach to an algae problem, honestly, but it's definitely something to consider. So I would say, with these three previous methods that we talked about, I just want to sign a word of caution around there are limitations to the effect. So like you could go and remove sludge tomorrow, you're not going to have a perfectly non-algae pond, right? And not only that, is that's not really even your goal. Your goal is not to have zero algae, right? Your goal is to manage algae. Same thing with aeration. You can go fix up all the aeration and replace it and get a new system in that's more efficient, et cetera, tomorrow. But it ain't going to mean you have zero algae. And the same thing with phosphorus precipitation. So, again, that to me that's not the goal. The goal is to manage the algae in a way that it provides the functions and the benefits that you want, while also on the effluent end not causing you to violate your permit for BOD and TSS and pH. So let's talk about a few other cheaper, let's say lower cost prevention methodologies that are available to you. So one is to use dye, and you can get these naturally biodegradable dyes. I used to live in Chicago, and if you know anything about Chicago, we have the St. Patrick's Day parade every single year, and in the St. Patrick's Day parade, they dye the river green, okay? And it's like this bright green, and it's a biodegradable dye, so it's great. It's fairly inexpensive, and the mechanism here is that you're preventing the sunlight from adequately penetrating into the water column, so that it can help form the algae on the bottom. And so I would say, this is environmentally friendly, it's non-chemical based, it's a safe kind of thing to do. If applied consistently, it's effective, and it's definitely cheaper than copper sulfate, which we'll talk about in another slide here in a minute. But the con side is it's proactive. So like if you've got a bad algae problem, this ain't gonna help you, right? Like it's too late. You should have been on this last in the spring, right? Not on this right now in the dead of summer. This ain't gonna kill algae that's already there. You do need to continually apply it, right? You've got water coming into your pond. This will be in there to a certain concentration. This will eventually filter its way out, and new water will replace it that doesn't have the dye in it. And so you've got to continuously reapply. And it has to be evenly spread throughout the lagoon. If you have pockets of your lagoon where you don't have this dye, obviously you're going to get algae growing in those pockets. And I'll talk about that when we talk about copper sulfate, because it's very similar in terms of the way you need to apply it effectively. Barley straw. So this one comes up a lot. People like this one. They talk about it a lot. And you could put barley straw in your lagoon, and the mechanism here is as it degrades, it releases chemicals that basically block the wavelength of light that algae need to grow. So they're specifically targeting the wavelengths that penetrate down to the bottom that cause the algae to form at the bottom as it breaks down, which is pretty cool, kind of a natural thing. And so it's very low cost. Might be the cheapest method. That pond dye, probably a toss-up. It can be effective. I'll give you a case study here in a minute of an operator that did it. But again, this is a preventative measure. So if you got an algae problem now, it ain't going to help you as much than if you started it in the spring or late winter kind of thing. You got to continually upkeep this. The barley straw does break down. You've got to replace it, replenish it. I've heard some mixed success. So I haven't surveyed the entire country of people that do this, and I don't know that many people that do. Some say it works, others say it didn't work for me. And so I don't have a lot of data to back that up, but I've heard of mixed success with this, and it will not touch duckweed at all. And the same thing for pond dye, won't touch duckweed. Both of these methods won't. Duckweed is a different animal. different animal. Literally, it is literally a different animal. It's an aquatic plant where algae is actually technically not an aquatic plant, but it's a bacteria that acts like an aquatic plant. So this is the case study here, Energy, Illinois. It's a 0.16 MGD system. The operator there utilizes barley straw. He's been doing it since 2014, so quite a while now. On his final cell, he just puts it in the secondary cell. He kind of lines it and strings it across. And he says he's had pretty good success with it. You know, a quote unquote pretty good success. So he likes it. Replaces it every 4 to 6 months. $30 per bale, about $600 a year. Pretty cheap, definitely, but it has been somewhat effective for him. So algae. Sorry, chemicals. So chemicals are big business. There's lots of companies out there that will sell you chemicals to kill algae. They'll sell you chemicals for anything. I'm sure you know this. They love to sell chlorine, all these different things. There are several different types of chemicals out there. I'd say the most common one that I'm going to focus on that you can use is what's called copper sulfate. This is the one that is the most common. I think it might be the least expensive and the easiest to use versus, you know, chlorine or other different things that are out there. So I'll focus on that. So copper sulfate is commonly used, been used for decades. It literally, what it will do is it'll raise, you know, as you increase the copper levels of the water, the concentrations, it actually is toxic to the algae. So this one will actually kill existing algae blooms. Sometimes you got to dose a little bit more, get a real bad one, but it will also prevent future algae blooms at the same time. Very effective, very effective. I would say, like with any chemical, read the label. Make sure you're taking the correct safety precautions for your, you know, human safety, and make sure you're not over applying copper sulfate and you're following the dosing recommendations. So I talked about this case study yesterday. I'll mention it again today because it applies to this copper sulfate and my experience with copper sulfate. So we did this study with the city of Chaffee in southeastern Missouri. So this is their 5-cell lagoon system, massive facultative ponds, all about 5 feet deep. In fact, now they're only 3 feet deep because they've got 2 feet of sludge in them. I mean, this is like an algae growing machine out here. It's a real bad algae problem. And they really do need to remove sludge here without a doubt. And so what we did was we were actually testing a new variation of our aeration product we call the Aries injector. And so we dropped an Aries injector in the final pond there where that blue star is. And we were like, hey, can we use this to feed copper sulfate, or in this case, chelated copper, which is like a variation of copper sulfate that is a little bit more environmentally friendly, and use that injector as we inject it into the center of our mixing tube. It will, like, you know, mix it up and spread it all around the pond, and everybody's gonna be super happy. And, you know, we just cured the algae problem for lagoons. So that was our vision. Now, I'm hyperbole, but, you know, we thought it might be useful, a useful tool, right? And so what we did was we actually measured, we dosed the algae, the algicide, the copper sulfate. We used a chlorophyll meter to test the chlorophyll coming out of the pond before and after, and massive goose egg. It didn't work. Massive goose egg didn't work. Okay, and disappointing that it didn't work. It really didn't help control the algae at all, and not because of the copper sulfate, because copper sulfate works, and that's proven. That there's no question about it. But because of the distribution methodology associated with it. So copper sulfate, think of it like Roundup, like a weed killer, right? You have to apply the chemical to the weed, right? And so if you look at this guy here, you know, this is what you got to do. You got to get out in a boat and you got to spray this stuff all around your lagoon, and you got to get it evenly distributed. And this is the same for pondi, right? And if you don't do that, you're going to get algae growing in the areas that doesn't have copper sulfate in it, and it's going to be less effective. So I'd say that's the biggest, like, pain in the butt part of copper sulfate in my mind, is that you've got to really get out there and spread it around. It isn't just like throw something out there to walk away kind of deal. One thing we did find, pleasantly surprised with this pilot study, and so it wasn't all for naught, was that we have a reactor, our nitrification reactor, at the back end of that polishing pond. So it goes through the polishing pond, through the reactor, into that, and then ultimately out the discharge. And so we're getting a lot of algae-filled water coming into the reactor. You can see it here in the picture, just green, right? And with our reactors, as we fill them up, we put a cover on top, and the water sits in there maybe 4 to 8 hours, depending on the flow rate. And what we actually found is that the level of chlorophyll, as an indication of algae, went down through the reactor. So we actually killed about 20 or 30% of the algae that went through our reactors, which I thought was really cool. So if you do need to meet an ammonia limit and you got an algae problem, the reactor is probably going to help you out with that. One other thing I'd like to mention about this is that, you know, when you use copper sulfate, it's killing the algae, and as it kills the algae, those dead algae cells sink down to the bottom, and they actually contribute to your sludge blanket, number one, and they contribute to nutrient compounding in your lagoon. And so they're contributing to the amount of fertilizer that's sitting on the bottom of your lagoon that can be used to grow algae. And so I like to think of this almost like it's like your lagoon ends up becoming kind of like a drug addict. And I don't, obviously, the analogy is a bit crude, but you know, like if what I hear is, you know, you continually need more and more drugs to overcome and get the hit that you need, and the same thing will happen with your lagoon, right? You'll continually need more and more copper sulfate over time because you're just going to keep compounding, keep compounding, keep compounding. So this is not a solution. In my recommendation, this is not a long-term solution to an algae management problem. Okay, it's not. You shouldn't be using it for that. If you are violating your permit today, and you know it's because of algae, then sure, go ahead and use it a little bit, okay? But in the long run, you got to treat the root cause analysis, and this is not treating the root cause. This is just treating the symptoms. So I really highly recommend that you take that mindset to it, because it's really not a great long-term solution. It's expensive as well. So moving over to duckweed, a couple things on duckweed. So one is you can use grass carp. This question came up yesterday. Grass carp is technically an invasive species, but if you buy neutered grass carp, which is what you want, by the way, and put them in your pond, about 5 to 15 per acre, they will eat the duckweed, which is great. And they also can kind of swim along the bottom, and they can agitate the sludge a little bit, and you get some benefit from that sludge agitation, and you get some breakdown of the sludge as a result of that. Funny story about this. One of our customers in Iowa had a lot of grass carp in their pond, and it actually wasn't on purpose. I don't know how they got there. They don't know how they got there. And what they came into to work one day, and were doing their rounds, and they got to the lagoon. They sat there, and they saw all these dead grass carp all the way around their lagoon on their banks. And not only were they dead, they were decapitated grass carp. I mean, just crazy. And what they surmised was, I mean, they were like, they thought that the start of the apocalypse had started to happen. But what they surmised was that river otters had come up from the river right next to where the lagoon is and where they discharge, and it actually fished out all these grass carp and just decapitated them and left. Didn't even bother trying to eat them, which is a little sadistic. And so that, I would say, is like one of the downsides of grass carp, is that lots of things want to eat grass carp. The other downsides are they only eat duckweed, and when they eat the duckweed, you're not getting rid of the nutrients. They're just eating them, and they're pooping them out, and that's contributing to the sludge blanket. And it could be a bit of an arms race between the grass carp and the duckweed, right? They're eating, grass carp are eating the duckweed's proliferating, and maybe the duckweed wins. I don't know. Duckweed it's tough. Algae and duckweed are tough things to beat. On the pro side, it's a natural solution, really kind of inexpensive, and it's very passive and easy. You put the grass carp in there and they do the job. So I'm not necessarily against grass carp personally. I think it can be a good solution to control duckweed, but there are definitely some downsides to it. The other thing you could do with duckweed is you can physically remove it. And so back in the day when I first started my career, me and my co-founder Brady had went to plenty of ponds and were using literally pool skimmers to scoop duckweed out of a pond. And the reason we were doing that is because when you remove the duckweed, right, you remove the nutrients that are sequestered in it, right? And so this provides a benefit, and you can potentially take that duckweed, you can compost it, you can use it as a great fertilizer. And so that, if you want to do that, you can do it. It's very manually labor intensive. I also found online, and I've shown this before, a little duckweed skimmer, an automatic duckweed skimmer that literally pumps the duckweed out, rolls it over a screen, and then puts the duckweed back in the water. Not the duckweed, but the water, and keeps the duckweed out. So this is kind of a cool tool. I could see this being used where you kind of put it out there in your pond where you've got a lot of duckweed, put it on a timer, have it run 2 hours a day or something like that, just to manage duckweed over the summer months, and call it a day. So one of the last things I'll talk about is covering. Covers are a very effective tool. This study here was done actually in China. They took 3 different sections of a really algae-filled lake or pond, and they had a section that had cover on it. They had a section that had no cover on it, and they had a section that had cover and aeration on it. And simply by covering alone, they were able to reduce algae by about 50%. And duckweed. I mean, I think this definitely works for duckweed, although this study didn't directly look at that, within about 5 days. And the pond with the section of the pond that had aeration and cover were able to reduce it by about 50% within 2 to 3 days. And so for me, what this says is that what you want to do is you want to be able to, you can leave the algae and the rest of the system, but you cover your last 5 days of retention only with some kind of cover, and that will help reduce the algae, which will help reduce the effect that algae has on your BOD and TSS at your effluent. There's lots of different cover options. We've seen the floating covers you can stand on, you've got the bird balls, you've got the hexagons, you got the rhomboids. There's lots of different options. These bird balls, hexagons are a little bit easier to install versus the floating insulated cover. They're all about $4 or $5 per square foot, so not cheap. Half acre, about 100K to purchase. But they're easy to install. They're like a set it and forget it solution, right? Like you put them out there, you don't have to think about it again. There's no chemical application. There's no preparation. I really like this. This is really my favorite. If I own a lagoon, and I don't, by the way, but if I did, I would do this. And we don't necessarily, we'll provide covers. We don't even manufacture one ourselves. But I really like this as a solution to algae because it really does. It's effective, it's passive, it's easy, it's so on. The downsides are, yeah, you're going to pay for it on the front end, right? You're going to pay a little bit on the CapEx side. And if you had a tornado roll through town or something like that, this is going to probably, part of this will blow away on you. Last 2 solutions, and then we'll wrap up and leave open for any questions. I don't touch on these a huge amount. These probably would have factored in previous presentations that I've done, but over recent years, I've kind of found these not to be as useful. But you can look at filtration. So up here, top right corner, this is a drum filter. We actually sell this through our sister company sells this through us. And this can be an effective tool. So this goes at the back of your plant. You pump through your lagoon, you pump through the filter, you go out to your discharge. And the filter has a 5 or 10 micron, typically more 10 micron type filter cloth on it that is trying to trap those algae in there. I've seen this work. I've seen it get down to 10 milligrams per liter in the summertime in terms of TSS, which is awesome. And BOD is obviously good at that point too. But it will constantly backwash in the summer months, like constantly, like all the time, almost 24/7. And so, it's fine, it works. It will just constantly backwash, which is of a concern. It really works best when you kill the algae first, and then it's easier to filter it out. But I would say the biggest downside to me is like it's CapEx, man, like, and it's OpEx too. Like you have to spend the money to put it in, you got to maintain it. And I haven't seen a lot of lagoons be really, really good at maintaining these types of mechanical pieces of equipment. And so in that respect, I wouldn't recommend it for an algae solution. If you're trying to meet a low phosphorus limit, sure, absolutely. But just for algae, I wouldn't put a filter, I wouldn't recommend it. The other one you see a lot of is ultrasonic. I've talked this unit here in the pictures from LG Sonic. I've talked to them numerous times. I think it's an interesting technology. It basically uses ultrasonic waves to mitigate the algae growth. However, I haven't seen it be effective in wastewater. I've seen it be effective. I've seen studies in drinking water reservoirs. I've seen studies in lakes and ponds. I've seen studies in their response, but I haven't seen it in wastewater, which I think is a little bit of a different animal. And so definitely, if anybody's done it before and has some success, do let me know. I'd love to have a case study on it, but I can't recommend it because I just don't know its effectiveness. So as we talked about here, you know, algae can have really good positive impacts on your lagoon system. You really want it. It's not about eliminating it, it's about managing it. And if you don't manage it, then it really has negative impacts. It can affect your effluent TSS, pH, total phosphorus, etc. I think prevention and really taking a really hard look at your aeration, your sludge management, your sludge levels, things like that, can be a really effective tool. And I think prevention is probably the best. If you're in a really, really bad spot, then feeding copper sulfate, or if you've got really bad duckweed problems, putting grass carp in, definitely good options, can be good, not the worst things in the world. I just wouldn't rely on them in the long run. And you know, the other thing to do if you have a real bad duckweed problem is actually physically remove the duckweed, which I think, you know, that'll somewhat solve the problem, not passively, but it will solve the problem. But ultimately, I think your best mitigation strategies are to look at your aeration, look at your sludge, and then if you need to, add a cover on the back end of the system, because it's just a really passive and easy way to deal with algae. With that, I am open to any questions that you have.
All right, Patrick, first question. With removing total phosphorus by chemical addition, when you remove TP from the liquid phase itself, doesn't that end up in the sludge? And algae growth starts at the bottom, so they still have access to it.
Yeah, so it does end up in the sludge, but it's because it's bound up with the chemical. My understanding is that it is less available for the algae to use it as a fertilizer. That's my understanding. But I'd say of all the strategies I've talked about, that and copper sulfate are the two least favorite ones I have for managing algae. So I wouldn't necessarily recommend it, but it can be effective at reducing the overall phosphorus available in the water for algae to proliferate.
Can you talk a little bit about the various costs and benefits of the different treatments? And obviously some things will work for both algae and duckweed, some will work for either or, but how do you judge when you've got like you're adding things to treat it, like chemical things? At what point does it become more cost effective to do a longer term solution?
I think you break it down like you break it down in terms of like, what's an acute problem that I have to solve? And if you have an acute problem, such as like you've violated your BOD and TSS permit 2 months in a row, and you need to solve this, and you've taken a sample and you've asked the lab to give you particulate BOD, and you can see that in your effluent, you can visually see that you have a lot of TSS that is algae. You can, you've got particulate BOD sample that tells you you have a lot of algae, because most of your particulate is going to be algae itself. And then I would say, okay, well, that's in a short-term acute problem. Well, now I got to deal with that short-term acute problem. And so I'm probably going to nuke it, right? I got to go out there and use copper sulfate, right? To meet my permit today. And use that as a tool to bide your time to look at the more longer term options, and start measuring my sludge, etc. Because overgrowth of algae and duckweed is an indication of an imbalance in the lagoon system, and it's an indication that something's wrong that you need to fix. And you should be addressing those root causes, which are the sludge or your aeration not working properly, etc. In the long run, versus trying to just band-aid the problem as a long-term strategy, which I just don't think is a good strategy.
I understand that barley straw needs to be added before the warm season starts. When is that? And also, doesn't that barley straw add more solids to the lagoon?
It does, and that's one of the downsides of barley straw, is that it adds some solids to the lagoon. I would say, so it's going to depend, like when to apply it is really going to depend on your local climate and when you typically see your algae blooming. And it'll vary. It'll much vary. I mean, the operator for energy, I think he said he applies it in February, and he's in Illinois, and he's, I think, sort of like middle of Illinois. I'd say that's probably pretty early, honestly, for that part of the country, but that's what he does it. And so it really depends on where you're at, but I think you want to do it before you get your first bloom going, because once the first bloom goes, you're toast. You can't, it's not going to do anything after that.
I'm open to more questions. We have a couple minutes left. Unless there's something else that you would like to expound on or summarize.
I don't think so.
I'll answer this question. Is the webinar available on our website? Yes, it'll be up on YouTube in a couple days, and I'll also add it to Lagoonversity in the next week or so.
Well, awesome. Thank you very much for coming. If you do have any other questions, feel free to reach out to me or Eve. Yeah, happy to respond any way I can and help out, regardless. Just like to be a resource to people. So thank you very much for coming, and thanks for being part of the webinar, and we'll see you next time.